I hope you guys are doing great. First of all, I would like to uh, welcome you in my class. And if you watch my previous video, so you can understand that how we can use the equations of motion and also what is projectile motion. So today's lesson is related to the previous lessons in which we are going to talk about how the projectile motion problems can be solved. I will try to solve 2 3 problems to make the things easier for you guys. For the projectile motion, so we will use this projectile motion in two types. In type 1 we will use only two equations, but first of all we need to know what is type 1. Type 1 is if a projectile is at some height. For example, this is a building and you are sending a projectile, like you are sending a package or a stone or something from here. So you will initially push this one, so this initial velocity v will be exactly vx, there will not be any vy, and then when it get into the air it moves like this. So the distance vertically covered is y here, and the distance horizontally covered from the base of the building to the point where it will hit the projectile. So here v will be vx, as it goes here it vx remains same, but vy will start because of the gravity as it is approaching. So vx continues to same, but vy increases to some value. So for this type of motion, you have to keep a few things in your mind. Number one, that initially there is no Vy, Vx is V, and acceleration as usual is always downward, and it will be G, that is 9.8 meter per square second, and we will keep this for the whole journey. So the equation that we need for this motion is, for the horizontal distance we will use x is equal to Vx into t. This is the equation for the horizontal motion, and for the vertical distance we will use y is equal to Vy naught t plus half gt square. But as you know that Vy naught is 0 here in the start, so we will put 0, so y is equal to half gt square. So keeping in your mind that there are only three components, only three physical quantities, four physical quantities that are attached here: x horizontal distance, y vertical height, then we will go to the other one, time, and the uh, Vx, the horizontal velocity. So to understand this, let me move to the first similar type of problem. There is a tiger that is leaping horizontally from a 7.5 meter high rock. So I will just say that the y is high rock is 7.5, so vertical height y is equal to 7.5 meter, and then its speed, because this is v, and I told you for this type of motion this is vx, that is 3.0. So just give me a second, I can just, vx is equal to 3.0 meter per second. So as it is jumping from the height, so it is type 1 question. So in type 1 they are asking us to find how far it will the tiger will land. Mean if this is the rock and tiger is going to jump from here, it will have uh, it will have this velocity that you can say horizontal velocity. So the horizontal velocity is, as I told you, a total velocity, that is Vx, and then it will jump toward the ground, so it is the going the projectile. So this distance they are asked to find. So for finding the x, I will use the first equation, x is equal to Vx times t. But understanding one thing, that I don't have t, so I need to find. And so first thing is they ask us to find horizontal velocity. So I am going to find x, the horizontal velocity. But the problem arises here is that to find the horizontal velocity, I need the time for that one. So for finding the time, I will go for the other equation, x is equal to half gt square. For that purpose, I am going to start with the first one, y is equal to half gt square. For this problem, g will be positive. So y is equal to 7.5 meter, half into 9.8 t square. So I can say 7.5 is equal to 4.9 t square. So t square is equal to 7.5 over 4.9, and then to remove the square I will take the square root. So I got t is equal to radical 7.5 over 4.9. So when I try to solve it, what I got, time is equal to 1.237. That was 1.237, and I make it 1.24 seconds. So we got the time for this one. Once we got the time, now what we need to do, we need to go for the horizontal distance. For that purpose, what we will do for finding the horizontal distance, the from base to the point where it is, I will use x is equal to Vx times t. As you know that Vx is here 3.0 and time 1.24. So if we simplify it, we can get the horizontal distance is 3.72 meters. So we can round into two significant figure, 3.7 meters. So this is your solution. Similarly, if I will go to solve another question, and this one is also similar, question number 18 of the John Colley book. There is a diver, so it's like the same. There is a diver that is running 2.5 meter per second, as I told you. So this is v, that will be equal to vx, it is 2.5 meter per second. And again, the time it takes to reach the ground is 3.0 second. So water, sorry, from the vertical cliff. So this is the diver that is diving from the diving board, and the diver is jumping from here, the diving board you can see, and when it will jump, you can say it will go like this. So this is the height of the board, that is y, and this is the horizontal distance, that is x. So here they give us that when he jumps, that is vx or v is 2.5, and it takes time of 3.0 second. Now how high will it be and how far? So they ask us to find x as well as y to find. So first of all, I will go for the y, because y is easy. I have time. I just need to substitute values. So y is equal to half gt square. So I got y is equal to half times 9.8 into 3 square. Time was 3 seconds. So this is 4.9 into 9. So it's around 45 meter. That is exactly 9 nines are 81, 8 remaining 36, and 8 44.1 meter for y, and for one significant figure I can write 44.1. When we move to the other, but if we will say only two decimals, so you can approximate it to 44 meter. Okay. Now getting to the other part, when we are going to find x, what we will do to find x, the same data we will use. And for x, what do we have? For x, we will go for example, x is equal to, sorry, I don't know, there is some problem with the pointer. So I'm repeating, x is equal to Vx times t, and you know that Vx is 2.5 and t is 3.0. So 2.5 times 3 is 7.50 meter, and we will round it to 7.5 meter. Okay.